Hello everyone, this is our final project for 304 Digital Enablers Laboratory at BUET. In this project, we demonstrate other estimated parking occupancy management system using Nexys A7-100T FPGA. Our system uses 6 HC-SR04 ultrasonic sensors to detect vehicle presence, tracks parking duration in real time, calculates bills, and outputs structured status reports over UART. Traditional parking lots rely on manual attendance or expensive commercial sensors. Our goal was to design a fully hardware-based solution that can detect whether a parking slot is occupied, measure how long a vehicle has been parked, compute the parking wheel, and notify an operator via serial terminal, using only combinational and sequential digital logic on an FPGA. This maps directly to real-world problems of parking management in shopping centers or hospitals, where a low-cost embedded solution is desirable. Let's go through the system architecture. The system is built from 5 Verilog modules. At the top is parking system slider, which wires everything together. The sensor module HC-SR04 multi-parking is instantiated twice, once for 4 parking slot sensors on PMOD JB and once for the 2 gate sensors on PMOD JC that counts vehicle entering and exiting the lot. Each instance gets its own echo measurement FSM, a 2-stage metastability synchronizer on the echo input, and a debounce filter to prevent false transitions. Internally, the modules also runs a per slot synchronous up counter that increments every second to track parking duration and debounce FSM that detects the occupancy falling transition and fires a 1 cycle exit pulse on departure. The bill calculator uses a 2-stage registered multiply divided pipeline. It multiplies duration in seconds by the rate in taka per minute, then divides by 60, spread across 2 clock cycles to meet timing. The UART controller runs a 10-state more FSM that periodically prints a status dashboard and on any exit event immediately prints a formatted receipt at 9600 baud. Finally, the 7-segment display module uses an 8-digit time division multiplexed scan. The right 4 digits show available slot count or the word FULL full when all slots are occupied. The left 4 digits show the parking time in minute second for whichever slot is selected by the slider switches.
Here is our physical setup. The brain of the system is Nexys A7-100T FPGA board that runs at 100 MHz. There are 4 parking slots. We used SR04 so my ultrasonic sonar sensor. These sonar sensors are connected with PMOD JB. The output of the sonar sensor is 5 volts, so we used a level shifter to convert the 5 volt logic level to 3.3 because FPGA input output pin is 3.3 volts. There are 2 gate sensor, one is entry and other is exit. They use a common trigger pin which is connected to JMOD JC. Then the UART output goes to the onboard FTDI chip to the PC where we monitor the output in PuTTY at 9600 baud. The slider switch here from S0 to S3 is used to show the time of each slot, how long each slot is occupied using 7-segment display. In the 7-segment display, we can see the number of empty slots. Let's say there is a car in front of slot 1. Now we can see that 1 slot is occupied and 3 slots is empty. It will show full while all slots are occupied like this. You can see that all slots are occupied. And let's say slot 1 is occupied. Then we will flip the switch 0 to show the time. This 4 segment will show that time in minute and second.
Key challenges and solutions. The most significant technical challenges we have faced was timing closure. Our initial implementation changed 32-bit divisions operation combinationally in bill calculator and 7-segment display module, which is produced a worst case negative slack of 80 nanoseconds. a timing failure. We resolve this by splitting divisions into a registered pipeline stage. The inputs are latched on one clock edge and the quotient is computed to the next. A second challenge was safely interfacing 5V HC-SR04 echo signals with the 3.3V FPGA input outputs. We resolved this problem by using bidirectional logic level shifter on the breadboard. In summary, we successfully implemented a fully synthesizable hardware-only smart parking system on an FPGA with sensor interfacing, real-time billing, UART output and multiplex display all in Verilog. Thank you for watching.